my friend.
Hey,
How you doing, Frank?
good, and you?
So far, so good. I'm live streaming from an unusual location today. I'm
PostGIS
attending,
conference?
PostGIS conference. That's my speaker badge. Enjoying, like, we have a 3 day packed of all things Postgres in the heart of New York in Manhattan. Nice weather, nice crowd, a lot of technical conversation. And just you're learning some insights, what's happening. So I'm just going to tweet a little bit about this stuff. There are some spoiler alerts, some extensions and improvements that are coming from different vendors who contribute to Postgres. So folks, if you are following us on Twitter, just give us a follow and you can learn what's new, what's coming, and we're going to cover everything in details. So what's about you? I know that you are traveling to Morocco next week. What's going to happen there?
Next week, Morocco DevOps, a big conference in the MEA part of EMEA. That will be nice, and I will run a 2 hours workshop to install Yugabyte on Docker. I will go there with Alil Dagli, with region manager in Europe. So we will meet people interested by databases, development on distributed SQL.
Excellent. Yeah, we need to popularize, the databases on the developer conferences, because still the primary users of the databases are developers. Like, they use databases, they create applications that sit on top of databases, and it's pleasant to see that many conferences, including DevOps, including DevNexus in the United States, and many others, they tend to schedule topics that are around their databases. People need to know databases. They need to learn SQL. They need to learn other APIs. They need to understand transactions, semantics, everything. So glad to. It's wonderful to see that you're returning to Morocco, right, next week.
I was there last year. We need to talk about it, because developers need to learn, but they don't have time to learn the deep details on all components they use, on all stack they use. So that's our job also, to give the right information, and not too much, but the right information, so that developer can be successful.
Actually, I think that they do have time to learn about databases. It's because the question is, how do they prioritize their time? Because when we talk about SQL databases, developers were told that, hey, SQL is complex, SQL is very wordy, SQL is the thing of the past, don't deal with it. And developers were abstracted by different ORMs from SQL. But if we let's say if we show like the capability of SQL to developers, we need to encourage them. And after that, they will start prioritizing their time to understand SQL better, to see what are the fun things they can do with that language. That's just my read. I think that it's all about prioritization.
And showing them how it can save time for them, because maybe it's easier to start on NoSQL, but then they have a lot of code to do that they don't have to do with ACID databases. So
Exactly. All right. So what's our primary topic for today? Hello, everyone, and hello, Eshwar. We're glad that you keep joining us every live stream. We have many folks who keep coming back to the community open hours of YugabyteDB, and just say us hi, like tell us where you're joining us from, because I'm in New York City right now. Frank is in Switzerland, right, Frank? Are you back home?
Yeah.
And we have a special guest today, Giovanni Silva, who is joining us from Brazil to discuss PostGIS, to discuss Spatial extension that was created for Postgres a long time ago. And that extension allows you to turn Postgres into a geospatial database. For instance, you can be storing different coordinates, locations, like stores, let's say location of different planes that are flying right now up in the air. And you can run different SQL requests that will do some similarity searches, or that will help you to understand how far, let's say, one Starbucks is from your current location, and do many other things like so let's invite Giovanni.
Hi, welcome.
Giovanni, how are you doing? How do you
I'm
feel?
fine. And here in Brazil, we have a nice day today because in this week it was raining a lot. But today is a good day. And
Which part of Brazil are you?
I'm in Rio Grande do Sul, which is very in the south. Yeah,
Okay.
we are the Brazil, in the city of Porto Alegre.
So basically, it means that, let's say, when it's summertime in the northern part, like of the planet, it's winter time
Yeah,
in your
exactly.
city, and opposite. So generally, you are getting ready for the summer, right? While
Yeah,
the northern part of the world is getting ready for the winter, and
yeah.
it's
And the summer here is very hot, and the winter is very cold. So there is no middle term like in most northern Brazil. You have a more midterm time, so you don't have this difference of in the winter and in the summer. But here in the south, it's very different.
Yeah, I can understand that. Like, I had a very wonderful colleague of mine. We used to work at the previous company. He lives in Uruguay, and he was kind of telling me the same story. It's like when it's winter time, he just enjoys, being in his home place because it's just wonderful weather. It's just warm outside. You can go
Yeah,
and swim in the ocean. But when it was summer in the United States, he was always like, "Oh man, it's like so cold outside. I just don't want to get
yeah.
out of the building." Yeah, it's
We
interesting.
don't
Like
we
the
don't
world is.
have we don't have snow here, unfortunately, because it's beautiful to see, but it's still colder.
All right, wonderful. We've already learned something. I think that many of our attendees who are watching us right now have already learned something new about the difference in the world. So, like, we know, like, that you are going to get at summer soon. And if you talk about your professional interest and then talk about your contributions to Yugabyte, just introduce yourself, what you do, what you usually build to the folks who are watching us.
Yeah, I work in IT for a long time. I started in 2007, uh, uh, but I have worked in Linux and in administration of systems, so I have a background in infrastructure. And I work in companies with the work internet companies providing internet access to some cities. And then I graduated in information systems, and which is very close to computer science. And I start programming in Java during the graduation, and I worked with Java since then. So I worked for some years with Java, and I work more in the back end develop and in the web development space. So I have a lot of experience in the web, like using some front ends with JavaScript and TypeScript, and experience with the back end in Java. And I learned Kotlin as well. I do know a little bit of Kotlin. I have worked with Scala some in the past.
Yeah,
Have
the
made
question is, the question is, what do you like more, front end or back end?
I like more backend because
Okay, that's yeah. That's probably why we have a conversation today, because usually
yeah,
if you are a backend engineer, backend developer, especially if you're a Java developer, most of the backend systems are running on Java these days.
yeah,
You have close relations with databases, and I think that's probably what led you to that contribution that you made into YugabyteDB, right?
yeah.
Okay.
I do work with a company which is ADP. This is a company which is we work with human resources systems. It's a very big company and has a lot of market share in the United States, and it's present in a lot of. I think they are present on all countries in the world, but I cannot affirm that. But it's many countries they are present.
Yeah, I'm sharing, like, for those who don't know, at least Frank, I'm not sure whether you know about this company, but at the one who lives in the United States, we use this company internally at YugabyteDB for the payroll and other HR related stuff. So it's very big and it's very well known, at least in the United States. The
Yeah,
United States folks should figure out what this company is about. It's a big one.
Yeah. I working with the backend development in a team on the next gen payroll system. So we do microservice development because we have a lot of different teams working on different parts of the process. I work in a specific part where it's kind of the middleman because I try to facilitate the usage of other human resources systems that are available to consume this new engine. And there's a lot of challenges in this, but we are trying to facilitate the migration to the new engine using this middleman in some parts of the process. So, yeah.
You know, like as far as I know, ADP doesn't use YugabyteDB yet, right?
I think no.
So like we need you just to champion this internally. You need to be that middleman that shows ADP that Yugabyte exists. And
We
that
use a lot of AWS systems. Yeah. We use a lot of AWS systems. We are probably one of the biggest clients of AWS, and in the AWS, Amazon is a client of ADP as well. So, is it two?
Do you know, like, do you know what type of databases the company uses, like PostGIS or MySQL? What?
My system using MySQL, but it's the Aurora version.
Okay. Okay, that makes sense. Yeah, different options, different styles.
Yeah.
Nevertheless, all right. So jumping back, yeah. Thanks for the intro. So like we've got and it's nice to have developers on our community podcast because as we discussed in the beginning, the Spring developers are the primary users of the database, right? And those databases are eventually created to support applications that are being built by the guys like you. So tell us, like, how you came across Postgres first and PostGIS extension. Like, why did you decide to explore Postgres with that geospatial extension? And then what happened? Like, why Postgres was not enough? Why you decided to consider Yugabyte and eventually contribute? Speaking about the contribution, right? You contributed a special Docker image that comes with a pre-built Postgres extension, and so folks, you can easily install it and use it. Like, tell us more a little bit about this story.
Yeah, I am a fan of Postgres because there's a lot of long time ago I start using open source databases, and I stick with Postgres as every time I try to build something and learn something and in a particular manner. So if I study databases or trying to build a system, so I always prefer to use Postgres because it's cheap to run. It's very efficient. So I do, when I'm working in particular applications, I prefer to use Postgres, but I have used it professionally Postgres and MySQL and Oracle. And then I'd start I'm living in a condominium, and I start using a small market. It's like a convenience market here in my condominium. And I find that very, very good business because it's very convenient. So you don't need to go to the supermarket to buy most of the stuff. So if you know home, you don't have coffee, you can just go a little meters and you have a coffee. You can buy a coffee. And this market, it's kind of taking off in Brazil. I searched a little bit about the market. There are some startups making offers in these markets. And I search it and learn about it. And I decide to build a system which will be serving this kind of markets.
Yeah,
so
if you let me pause you for a second, I just want the folks to see what exactly you're referring to, because we had this conversation with you a couple of days ago, like this convenience stores. If you folks ever heard or about 7-Eleven, that's an example of a convenience store. Like here is I'm on Manhattan right now, and here is I'm looking for the nearest 7-Eleven locations. So visually it looks like this small store that is part of the like some apartment building. If you take a look at the pictures, it's open 24/7, right? And you can buy the basic stuff like eggs, bread, some beer, water, whatever you would like to get, some basic stuff. It's very popular, especially in big cities.
Yeah. And here in Brazil is not so popular, but after the pandemic, it is starting to take off and get traction in the market. So I saw opportunities to build a system and maybe build a startup, build a MVP about these systems. And one of the things I need to do is to find the closest markers to the person given the geographic position. So imagine you have a mobile application and you open the application will show you the closest market because you want to consume from your condominium. That's the business model we have. And that's one use case for using PostGIS because I can save the position of these markets in the PostGIS database and do some operations to find the closest one. And it's a differentiation for other systems that I studied because I can then make some questions like which are the markets what are the products that are low in stock in this particular area. So you imagine that my client, it's another business that create this kind of market. So it's a SaaS system, but it's a business to business model. So they will have a lot of markets, a lot of contracts with other condominiums, and they need to operate the stock on these condominiums, and they need to sell these products on the condominiums.
So basically, the use case, like, let me try to answer this from the user standpoint. Let's say that I live in some, apartment building, some condominium in Brazil, right? And it's like late night. Probably all the stores are closed, but I want to make an omelet, right? And I want to get some, sandwich done. I don't have anything left, right, in my house, and I'm opening your application, and I'm checking what's the nearest convenience store near me. And I also, before going to that store, I want to make sure that they have eggs and bread, right, available in their product catalog. Okay, that makes sense, because usually because I had that question, like, why do I need this service if I can go to Google Maps? But if I go to Google Maps, I'm not sure. The Google Maps doesn't show me, does that store have bread and eggs for my late night dinner?
Yeah.
Okay, makes sense.
Makes sense. And so from the point of the user, it's very simple to use, and they can buy the stuff. It's autonomous market, so we just go pick up the things and pay in the toting, which is autonomous. And from the perspective of the business who operate this kind of markets, they need some informations to operate, like, and they need to know the low stock. They need to know how to, maybe some things about how to minimize or maximize the efficiency of the transfers for these markets. So
yeah, that makes sense. Yeah, that makes sense. I think that we've got a pretty solid understanding of what the service is capable of. And then the question is, okay, you've got Postgres and PostGIS extension to process the location information, right? First, you want to process location information to show to the users the nearest store location, right? And why YugabyteDB? Like, why YugabyteDB? Why Postgres is not enough? Like, what's the point of having YugabyteDB?
Postgres is really good, and I don't, as I am MVP, I don't need the scale. I don't need to I don't have a huge scale, but PostGIS is kind of difficult to scale, right? It's difficult to scale with highly available. If you mix the two, there are two different things, but if you mix the two, then you spend a lot of resources and operational building and operating this. And one thing that have one thing that YugabyteDB has and experiment a little bit, it's the building highly available, and it was very easy to build. And I was used just 3 instances. And I thought this is more cheap. Don't have standalone read-only copy, and then mixes. This is more cheap, so I can build the high level because I need the minimum of 3 to be highly available.
Actually, yeah, that makes sense. Like, that's a good way of thinking. Like, even though, like, as a startup founder, you understand that in the beginning you probably don't need to have, let's say, multi-node cluster, but you already think about high availability, because once your service gets some traction, you will get the users, you will get the vendors, right, who will be, updating your product catalog in those convenience stores. You want the service to be highly available. You don't want it to go down. Okay.
Yeah, I don't need the scale, but I want to have high level availability at the beginning, and I need that because if I get some traction, or I can lose customers because of a downtime. So this has to be building from the beginning. And it's, for me, it's more operating a Kubernetes cluster, and for me it's more easy to operate Yugabyte with its high availability system, because it's more easy to operate.
Okay. Speaking about the cloud environment, you're running this in the cloud environment, right?
Yeah, using Oracle Cloud.
Yeah, and Frank, let me ask you a question to Frank. Frank, do you know why Giovanni uses Oracle Cloud and not any other public cloud
provider? The Oracle Cloud is quite cost efficient because you don't pay for inter-AZ network.
Hell, you know that, man. It's like Frank is used to be Oracle champion, right? And you know a lot about, not only about the database, but also keep an eye on what's happening. I was just, I was trying to put Frank in like the difficult situation, like just trying to ask a question that he would not be able to answer.
Yeah, that's the point. It's cheaper because in Brazil we usually don't have much offers of. We have the big ones, AWS. We have Microsoft, but they usually charge different from country to country, and it's usually way more expensive here in Brazil. And Oracle Cloud, it's the same price in every country they have. So
yeah, that's also interesting. You don't have to choose the region because of the price. You choose the region because of the latency with your users and data governance rules. Yeah.
That's a nice approach. Any other public cloud provider follows this pattern, or only Oracle? No.
I don't know. In the big cloud providers, I don't know. I think the others all match the cost of running a data center in the different countries. And that's a special choice from the cloud provider, because, for example, I live in Switzerland. Running a data center in Zurich is probably one of the most expensive when compared with other countries, but it's still the same price for the services.
No, that's wonderful. That's a free advertisement for Larry Harrison, even though we don't have a huge number of viewers, at least right now. But still, yeah, kudos to Oracle for making this happen. And I like what Oracle does is, it's really easy to start with. It's for me at least, the one who is not Oracle expert, it's extremely hard to start Oracle on a local machine, but it's just a few clicks away if you go to Oracle Cloud, autonomous database for free, and it's always free if you want to experiment with Oracle.
So Giovanni, you are running that on the managed Kubernetes on OKE? You are running Yugabyte on the managed Kubernetes on
Yes,
Oracle
yes,
Cloud
on the
or on
managed
VMs?
servers. Yeah,
Yeah.
the managed servers. And other thing, but Oracle does is that the managed servers is free, and so you just pay for the resources you use. And I use their ARM version of the resource because they are cheaper, and I experiment a lot of images with Kubernetes, and most of the things I'm using works. Some I have tweaked a little bit. They could be compiled or something, but I haven't good experience with ARM servers, ARM architecture.
Okay. All right, folks. Let's see how this works in practice. Because I remember that Giovanni, you promised us to show a couple of typical queries that use PostGIS and YugabyteDB. Just show us something in practice. As a developer, I'm always curious to see how things work and sometimes how things break. But hopefully, nothing will break today. Yeah, like if you want to share the screen, you need to, down below, you will see the present button. Click the present button, and then pick your entire screen or whatever you have. And we will get it edit or window, or window.
And in the meantime, if in the chat people have tried the Oracle Cloud to run Yugabyte or I've tried the Kubernetes, it's also interesting to get feedback about that. And maybe I can mention something that we didn't mention. The PostGIS is for spatial data, and people who are not used to it may think, why do you need something different to store the location of shops or anything? The thing is that spatial data has multiple dimensions. You cannot just store one value. You have to store a point or a line or a polygon on a map. So it's kind of a vector that is stored in the database, and there are many functions coming to manipulate that.
Yeah, that's exactly it. PostGIS has a lot of functions, and you can store polygons, you can store points, you can store and you can do queries like correlations between which points are inside this area. That is a lot of things you can do. You can basically build a map using PostGIS. So this is currently the server that I'm running. It's a highly available service, but it's a staging environment. So we have 3 masters and 3 servers. I'm using the Yugabyte repository shard to build this. So it's the same link. I just changed it, so you can get in the Yugabyte chart. But I just changed the image, so you can use the same infrastructure that Yugabytes have provided to build a cluster in Kubernetes. Just changing the image, and it should work.
So yeah, generally to remind our friends who are watching us. So your contribution to YugabyteDB, the current one, is that you created this image is the latest YugabyteDB version and PostGIS extension that you can run on an ARM virtual machine, right? And that's actually what you use in your Oracle Kubernetes environment.
So I just changed the image. This is the last build I have. And this is our ARM architecture. So it's working good on ARM architecture as well. Okay. Just to show that I'm using the cluster, and I have a direct connection to the cluster.
We don't see. We just see the sun. Yeah, looks like something disappeared from the screen.
Yeah, because you shared only the window and not the screen, I guess.
Yeah, just try to share the window.
Okay.
Oh yeah, like this. Okay.
This is the application I'm building, and this is a staging environment. And currently have this is automation environment. So I just push the code and the environment is built. But we have some usages here. It's in Portuguese, so I will translate to you, but I hope it's a little bit intuitive. So here is where I'm using. So we have products and a list of products. Let's instance this. Forget the name is in English. In Portuguese, we call biscoito.
Yeah,
It's a
biscuit.
wafer.
Biscuit.
Wafer.
Yeah, yeah, waffle. Yeah.
Yeah.
Yeah,
So
some stuff with sugar. Yeah.
we have products
Oh,
in
Heinz,
the
we have it.
database.
Yeah, yeah. It's like it's international products. We've got international
Yeah.
stuff. Okay.
And we have a stock of the product that we have that we can control here, and what I imagine is that these companies would have a main stock where they have let's suppose a building where they concentrate all the products, and then they transfer the products to the markets. And
Okay.
here we have the markets.
And markets, like what you call markets, are actually convenience stores, right? Like
convenience
7-Eleven.
store, yeah.
Convenience store.
So we have two markets here, and I can create a new one, and you'll see that I communicate with Google APIs to build this map. And if I put a SAP, I communicate with Google, and I get the location for the map, and I get the address as well. So we put this new store 3. So, and this point, it's in YugabyteDB as a point geographic column. So it's just a point, and we can see, visualize the map, all the stores that are for this particular company. So I have to build some. I will have to build some isolations in the database, and that's the point where YugabyteDB is also interested, because I can spread the data. If I scale, I can spread the data inside the YugabyteDB using the organization as the key. So the organization could have the data closest to to the store in the YugabyteDB, and I can isolate this better. And the other thing that I will use is the whole level security of the YugabyteDB and PostgreSQL to isolate the queries and use one table, but with multiple clients data inside this table. That's the strategy I'm following.
Okay, that makes sense. That's clear. So, like, for instance, can you show us how your typical SQL queries look like? For instance, what the application code executes over the YugabyteDB database and PostGIS extension, just to understand how you calculate that distance and some basics, so that the folks can translate. Like, there's the UI, that's your front end, then you have backend. Backend is Java.
Backend is Java.
Yeah, Java and then Java.
So we can start with simple queries like given two markets. So let me show the markets database. Tables market. So we have this location where is the point, and we can start finding the distance between two markets, right? So the market with ID1 and ID2, and we can find the distance of this. So
okay, the basics, like, right, for instance, you want to decide, like, you as a vendor, for instance, you have some products, right? So some product, you need to ship those products to the stores, right? And you need to decide what's going to be your route, for instance. You need to deliver to both locations, probably you want to.
Exactly. So PostGIS has a lot of functions to operate in this this geographic system, and they have a different, which is the geometry and the geography kind of point. So I'm translating the location to a geometric point, I could use geographic. The difference is that geographic, it's on meters by default. So in the system of meters, and the geometric, it's not in meters, like it's on unity on planar degrees. So you find this distance, which is not it's 0.36, but it's on planar degrees, so you cannot translate to a human point
You
of
need to
view.
translate to meters, to kilometers, or miles, whatever you like or get used to.
Another thing we can see is the location in the store. So we can find the points that are the locations on the store. And
it's like exact location, right? And for instance, you can use this location then to display the store on your map, Google Map, right, or any other map that you use in your front-end application.
Yeah,
that would be the use case. Okay.
Yeah, that's where I use I show the map now, and I can show every point, every location of the store using my query like this. And we can one use case is to find the closest store given a location of the user, right? So suppose the user is on this point, so I get the location in the GPS of the user. I'm finding the distance between this point. I find the markets distance of all markets, and then order by the distance. So to find the closest. So if I run this,
that's the use case, guys. When that's the use case when, let's say, Denis, who travels to Brazil and finally he wants to make an omelet and he needs bread. I open up my mobile phone, and actually this mobile phone sends my current location to your backend, Java backend, and Java backend eventually will execute a query like this, right, returning me the nearby stores.
Yeah, we will find the nearby store. And for my particular case, I will have a trash shot, so I don't want all the stores. I just want the very close stores. So suppose like 20 meters or something like. So we'll have a trash shot to filter the distance in the squares.
All right. Makes sense.
Now, the next use case is, suppose I have some transfers. So I have these products in the database, and I transfer the product to the markets. So I already run this query, but I will insert in the market stock the products and the quantities of the products that are available in these stores. This it's a little more complicated because we have approval, but it's still on working, right? And I don't have an interface to do that. But we transfer some products to the database, and we have the data of the transfer, when the product's gonna the validation of the product. So if the product is, suppose a meat, right, and it has a validator data.
Like expiration date, date of the product.
You have expiration data, and in the future we have to make decisions like which are the products that are on the validation close, so I can remove or make a promotion to sell quickly. So this information, it's good to have. And then we can start making some more specific questions like which are the products that has the content, which are the products in the markets that has a quantity lower than 5. So suppose the user has a configuration and he says in this markets or in this region or globally, this product, if has less than 5, I need a report on this, or show me an alert that it's on a low quantity, so I can plan another transfer to this market.
So generally, like that's something that is certainly necessary for the store vendors. Like for instance, when they need to be notified when something is running out of stock and they need to deliver, to ship new products, but also for the user, right? Like for me, again, I want to cook this omelet, and you gave me several locations nearby. It's already late night. I want to go to the location that definitely has eggs, bread, and probably some soft drink. So that's also my use case for the user, right?
Yeah, that's also a user case.
Okay, excellent.
And
actually, if you let me to pause here, and actually, folks, here is one important kind of moment, because there are many specialized databases. Like you can see different cycles. Like once in a while, you've got a special graph database, then you've got a special vector database, then you've got a special geospatial database. So many special databases. But in the real world, usually you want to mix data. For instance, if you're doing some similarity search, you want to find the nearest locations, like for the bakeries, like when you're traveling somewhere, you can write this down, this query. Yes, you can use those vectors, right? Just to find like whatever, like some of the location that will meet your prompt. But then it's not enough. Usually you want to get some other data that is stored in your database, like how many products, what's the quantity of these products, etc., etc. And this is where relational databases can shine. Relational databases are easy to adjust. They're flexible. You can introduce, let's say, this new data type like geometry, like different points, etc. And you can mix, you create queries that will consider geographical location with other data that is necessary for your request. And you don't need to use multiple databases. It's all in one database.
And in the same transaction, you commit both. You see a consistent view on all. If someone is changing, I don't know, the product catalog in the shops, and another one is changing the location of something, then yeah, it's all consistent.
Excellent.
Yeah, exactly.
All right.
Okay. No, there are select some marks that are inside the box. Higgs experimentation of finding the markets that are inside some polygon in the map. So suppose the user wants to find the stock, or it will depends on the use case, but as you mentioned, we have the data on the same database, so we can make these correlations. And what I'm trying to do here is that the user will select a geometry in the map. The simplest way to do is just to make a point in the center of the map and then expand to an area. Like you can expand the point to area and find the markets that are inside that area. And this can be useful for reports. So suppose because it's difficult to correlate if you just have the address, right? If you just have the address, you can you can make some queries like this. What is the neighborhood?
The use case is pretty clear. For instance, if just to speak again about my omelet situation, right? It's late night, and imagine that I'm not home. I got stuck in the office, and it will take me, let's say, 30-40 minutes to travel back home. Like I will take a subway or bus, whatever. And I have like convenience store nearby my office, but I don't want to take and bring those bags, on the subway back home. And that's why I open your application. I know where I live, right? I go to the section on the map where my house is located, my apartment is located, and I'm just telling you, right, search for the nearby stores that have the omelet, bread, and soft drink right now, because once I arrive home, I just want to stop by that location.
Yeah.
Right. Okay.
We can make this as a report. We can start doing some more sophisticated things, like building live dashboard where the system sees a map, but according to the zone level of the map and the area he's seeing, I show information from the business he's running. So it is experimentation, but I think it has a lot of potential to show informations inside a map, especially in this kind of business where my client will have many markets spread across the city, and he has to know informations of these markets to make decisions more efficient.
Wonderful.
Unfortunately, this is not working in YugabyteDB yet, because we have a problem with some libraries in C libraries that are not compatible. So it is giving a exception in this query. But
here we go. Like you disappointed me. I was thinking that like everything works out of the box. But yeah, jokes aside, folks. We don't. YugabyteDB doesn't support all the capabilities of PostGIS, because but it's up to you. We are open source. If you have any capability, you can always vote up. You can find a feature request on their GitHub. You can vote up for it, and eventually it will be supported, or you can contribute to it. So we usually like start working on the stuff that has the much larger priority. So, but nevertheless, we want to be honest with you that not 100% of the PostGIS geographical extension capabilities are supported by the database yet. But for the essential stuff, you will be able to achieve it, right?
Yeah. I think we can make all the features of PostGIS working in Yugabyte, because I was pretty well impressed when I'm when I make it work, installing the PostGIS installation. Just try a few queries and saving the data in the database, and it's worked great, and with no effort, no additional effort. But when you try more sophisticated queries, it crashes in some libraries. So it's a case of C library compatibility, but I'm very confident we can make that work.
Yeah,
maybe we can explain shortly the problem. Currently, we ship Yugabyte with a specific version of glibc, which is nice because people may have heard that in Postgres, they had some index corruption because of different version of glibc, to make it quickly. So we ship with specific version of glibc, but there are some incompatibilities when we add new libraries like Postgres. And actually, it was tested on CentOS 7. And there are a few libraries, I think the XML1 and an SQLite one. I don't know why Postgres is using SQLite, but it is. And there are a few ones. I've seen what you have done to build your image. You have taken those libraries from CentOS 7 to put it in Alma 8 or similar. Yeah.
Excellent. Yeah, let's see. Actually, let's do this. Thanks a lot, Giovanni, for demonstrating how that looks like from internally. So you just demoed us. You explained everything. You explained us the business use case. You showed the UI. You explained the backend, and eventually you showed what happens at the database layer. And I know that also that Frank, you also prepared a few examples.
Yeah. Maybe we will first answer a question from Eshwa, asking about what if you want to get live data directly. So rather than loading off the spatial data, getting live data from online services. I didn't test it, but I will put the link to with Postgres. There are many foreign data wrapper, which basically help to query other databases, but other databases can be other data sources. And I've seen that there are a few foreign data wrappers that you can install. So contributors can test it on Yugabyte and query some information. Like I see, for example, OpenStreetMap that is running on Postgres, but there is also a foreign data wrapper. So maybe if you just want to more information from a map, like adding the streets or whatever, maybe possible with the foreign data wrapper. That's a possibility. And yeah, I can show you. I also played with Postgres and the image built by Giovanni. So let me share my screen. And to play, I played with the New York City data.
Good choice.
That's
Good choice.
the spatial data for the PostGIS tutorial. And I know where you are, Denis. You are at the PostGres conference at PostGres New York. So yeah, that's a bit long. So we know where you are. I got the latitude, longitude from where you are, and I will query what is around you in New York.
Okay. It's hard to hide from you, Frank. I
So
mean, come on.
yeah, but that's convenient because the New York the data set that is used for the tutorial is about New York, and you are in Manhattan. So yeah, that's just perfect timing. So basically, maybe I should mention something that I didn't know before looking at PostGIS. So this is the latitude, longitude, the point where you are according to Google Map. And you can see this number. This number is a SRID, where I don't really know the detail, but the idea is that there are multiple maps. And in the geometry, we have points within maps, but there are multiple maps. And this one, latitude, longitude, I can get some information. With Postgres, there are also some referentials, and this number is just the special code for the longitude, latitude one. But the New York spatial data that I have uses another one, which I don't know if it's used a lot, UTM, but I just converted those coordinates with dot points in this different map. There are multiple ones, and yeah, those are pretty standard. All that was not invented by Postgres. It's used by all spatial systems. And then let's query. So let's first show which kind of tables I have here that I imported. So I have information about streets. I have information about subway, neighborhoods, and also homicides, because this comes from the census information. I don't know exactly from which year, but yeah, that's just information. So basically, I can run a query where I get the distance. So same thing as Giovanni has used to see the distance to the next shop. So you can see that here is the point where you are, and I will just query the distance from the subway station. Let me order on the distance and take the first one. So probably, if I'm not wrong, and if this data is right, the next station from the Postgres conference where you are is Grand Central, and this is the distance in meter, I think, because we are in geometry.
Yeah, Grand Central, yeah, is nearby. It's just probably around the corner. Yeah, and you have this color
so
because there are many
I would
lines.
say 300 meters, and you have 3 lines: the green, the purple, and the gray. Yeah.
Okay, thanks for the information. Like, if I decide to go somewhere, I know like that's just 200 meters away from me. Okay, that's good. What else? What else? What else?
I'm running a similar query there. So the first one I just limited to 5 rows, but as we have seen before, as Giovanni used, I will not take just the 5 first one, but the ones within 1 kilometer. So here I've added a where clause with a within clause between 2 geometry: the point where you are, your location, and the location of the subway. So basically, you have the 10 rows that are less than 1 kilometer there.
And you can certainly order this by distance, but right by the final distance.
And I can order this by distance also. I can also query other table. For example, I have a table with neighborhoods. That's the neighborhood of the different places in New York City. And here I'm using a contain function because neighborhood is an area. And I want to know which one covers this point. And there is one, and it's called Midtown there.
Yeah, that's Midtown. Yeah, that's Midtown.
Maybe I will just add, I'm running the same query. I will add the geometry to show exactly the difference. You can see that here, for one specific location, I'm using a point, but the neighborhood is more than that. If I query the geometry and show it as text, you can see that this Midtown neighborhood is a polygon with multiple points. So that can be quite complex. And this is how you can say this polygon contains a specific point. And maybe looking at the time, but maybe showing something. So probably you want to compare some geometries. So for example, let me first run again the previous query. And set a variable. So this ribbon set this. Oh yeah, because I was pager that I usually disable. I set a variable from the columns there just to use it for another query. So here I will query the subway stations that contains. Now I'm using the result from the previous query that I've put in a variable. So from this point, I can query. So from this neighborhood, I can query which subway station are there inside it.
So generally, you've just returned all of the subway stations that belong to the Midtown of Manhattan, right? Because the previous query was return the Midtown. Okay.
So that's what we can do, but because we are in a relational database, we can simply do that without a variable just by joining the tables. So here I'm joining the subway station and the neighborhood. I'm looking at one specific neighborhood, and my join condition is this contains clause. That's just tell me that the neighborhood contains the subway station. And this gives me the same result. Sorry?
You can also put geometry in index, which is really interesting as well. You can put a point in the index and query more quickly, comparing the geometries just like you did.
Yeah, in Yugabyte for the moment we don't have the GIST indexes. Maybe I can plan to see what happens there.
You've just got a question from Alex Peralta, who said that the documentation doesn't currently support GIST. So right now, kind of we don't support this index as of now. We have a ticket. If you are interested, Alex, we can send you a link. You can watch it because sooner or later it's going to be available in the database. But in the meantime, like all of our customers, all of the users who use PostGIS, they generally kind of all right with their, let's say, full scan, because they can distribute across multiple nodes and they can run the full scan across multiple locations. And sometimes, I mean, what can happen in the full inquiry, right? What Franck has, right? It has the where clause for several columns. Like the first column is, let's say, Midtown, and generally you can you can run an index search using the Midtown location, and then you just have a subset of the data, and for that subset of the data you might not need indexed for the geography. So not supported yet. And Franck explain why not out of the box.
You can also create an index. For example, if you have 2 points within the same table, you can create an index on a distance because the result of the index is not a geometry. It's something that we can index. But for the moment, we don't have the GIST indexes. The thing is that we will implement GIST indexes, but a lot of people are also asking for other kind of indexes, like vector indexes. And our idea is not to develop a different kind of index for anything that exists or will exist. So if we can build something that can help for any kind of vectors, spatial, but also embeddings, maybe we will do that. So that's why it is an open issue. Just looking at people who ask for it, how they want to use it in order to decide for the best implementation for it. Yeah. But for example, I was looking at the execution plan. This one is not bad because you see a nested loop, but the table is materialized. So even if there is no index, we have all the join methods that Postgres offers.
What if you do the table is small? Like, what if you create the index on the neighborhood name? I mean, I'm interested. Will it do the index search for the neighborhood name?
Yeah, on the name, of course, I can do it to avoid the scan on the neighborhood. So, for example, this one I can index, and then it will be materialized. But then the filtering on the contains, this one, the join filter, will be applied for each row on the subway station.
Okay, wonderful.
So
okay,
depends on the size of table. If you join two big tables, then better to have an index. If you have a big table and a small one, then maybe that's sufficient. Yeah.
All right, my friends. Yeah, thanks a lot. We are already a little bit over than 1 hour, and we just need to wrap things up. So just the last 2 minutes before we close the stream, if anybody has any questions about what we just discussed, send it to LinkedIn, YouTube, wherever you are watching us from, and we'll get an answer. In the meantime, I just want to say thank you, Giovanni, for being an active community member. Thanks for finding time to contribute the Docker image for the ARM and with PostGIS. I think that many will find it valuable because ARM is becoming ARM CPUs are getting traction across all of the cloud environments because even Amazon Corretto, right? They have their own CPU, and that's an ARM-based CPU. It's just
yeah. Amazon has Graviton, Oracle has Ampere. I'm not sure what is available on other cloud providers, but yeah, that's interesting. Yeah, and those contributions are really helpful for other users, but also for us because you build an application and then we have the feedback about. It's not only about building features, it's building feature that helps developers. So it's always interesting to have use cases behind the features that are in the roadmap.
Nice. Okay. Thanks for calling me to this talk. I appreciate it. It was really interesting to see, and very good impressed by the number of talks that are doing in YugabyteDB every week. So it is very nice, and I hope the community keep growing and we can make more use cases available for the usage of YugabyteDB.
Yeah, absolutely. Yeah. Keep staying in touch with us. Keep contributing, and we'll be happy to invite you back to this show, to this live stream, so that you can educate all of us on what's happening, how do you use YugabyteDB, how you contribute to YugabyteDB. We'll be very happy to host you once again in the future. Thanks a lot. All right, and thanks Alex, also for joining us. Yeah, thanks for staying with us, and thanks for asking your questions. If you folks have any other questions that you want to ask offline, go to Slack channel. We always monitor it. We're keeping an eye on the Slack channel, and we'll see you in a couple of weeks.
Bye.
Bye.